Hello, and welcome to the Radians, Degrees, and Coterminal Angles video. In this video, we're going to be going over a lot of information that is just kind of laying the groundwork for what we'll be doing for the next few days. Specifically talking about some terminology, just making sure we're all on the same page. So let's start with just the terminology of angles. So for angles, angle might look something like this. And this is actually going to have three different parts to it. We have a vertex, which is kind of this corner right here. We have the initial side, or you can think of it as a starting side, and then the terminal side. So you're going to hear me saying all these things. And when we read an angle, we are going to be reading it in this direction or counterclockwise. So these are all the different parts of an angle. And when we're looking at it on a graph, because we will be doing it on a graph, if you have your initial side, where's my highlighter? If you have your initial side right here on your x-axis, that is going to be in something that we call standard position. So whenever we're trying to find angles, for instance, on our unit circle, they are all going to be in standard position. And we'll have something, for instance, over here. Let's call this our terminal side. So when we talk about our angle, it'll be from our initial side to our terminal side. That's how we're starting it. Now, what if we went clockwise? What does that look like? That is something we can possibly do. It just means... Oop, that is not a straight line. We'll pretend. Okay, that's marginally better. So if we have something like this, not straight, don't care. And then this is our initial side. If we have something, for instance, out here again, to be our terminal side, if we move in this counterclockwise direction, we're going to call this a positive angle. And that's when we move counterclockwise. And when we have something going the other direction, we're moving this way from our initial side, clockwise, that's going to be a negative angle. So if we're dealing with negative angles, it just means that we're going the other way around. Now, something special about these is that if you have angles sharing your initial and terminal sides, they are coterminal. And we're going to talk about coterminal angles in just a moment. But before we do that, I want to talk about how we might measure our coterminal angles, or angles just in general. And that's going to be in radians and degrees. Right now I'm going to focus on radians since that's the one we seem to have the most trouble with. So a radian, we can define that as, let's see, a radian is a central angle that intercepts an arc equal to the radius. So you can kind of think of that like arc length, but we're talking about the angle that is kind of equal to that arc length. And whenever we're talking about this angle, we're going to be using theta. So this kind of circle with a middle through, with a line through it is called theta. We're going to be using that instead of x, because we're going to be talking about like x for side lengths and coordinates and things like that. So whenever we're talking about an angle, we're going to be using theta. So if I was to kind of draw this representation of a radian, circle. So if we say, okay, from the center to the edge of the circle, that's the radius. We'll have a radius here. Here's our angle of theta. What we're really saying is that, hey, this length right here, we'll call it S for sector length, is equal to that radius. So 1 radian might look something like this. And since the circumference of a circle is 2 pi r, 1 full circle is equal to an arc of 2 pi r in length. So for us specifically, since we're dealing with the unit circle, we can say that if r is equal to 1, then for us 2 pi r, or 2 times pi times 1, is going to be about 6.28. So technically there's 6.28 radians in the unit circle, but instead of dealing with the decimals, because that gets kind of messy, we just leave it in terms of pi. So let's take a moment to talk about how we would divvy up those radians if we were to graph them. How much space? Oh, I forget that we're not on an actual page, so I can just keep on going. Okay, so again, for us, r is equal to 1, so our circumference of 2 times pi times r is really 2 times pi times 1, or just 2 pi. So if I was to draw a graph, we'll call this quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We're going to go around and say, hey, where is, how are we divvying up our radians, and where are these radians happening? Where are these angles? So we start over here at 0. If I want to just look at 1/4 of the circle, or a quarter of the circle, I'm going to take my whole circumference of 2 pi, so all the way around, and I'm going to split that up into 4, but if we reduce that, that's going to be pi over 2 radians. So that's going to be up here on the topmost arrow, so it's going to be pi over 2. So anything in quadrant 1, all of the angles is going to be between 0 and pi over 2. So everything in between quadrant 1 is between 0 and pi over 2. If we were just looking at half of the circle, I'm going to take our full circle of 2 pi, split that in half, and we're just going to get pi radians. So over here to the most left, we're going to have pi, and anything in our second quadrant is going to be between pi over 2 and pi. This is just kind of helping us remember where does everything go. If we want 3/4 of the circle, we're going to take 2 pi and multiply it by 3/4, leaving us with 3 pi over 2 radians. That's going to be down here at the most bottom arrow. So we can say that in quadrant 3, all of our angles are going to be between pi and 3 pi over 2. And then lastly, just a reminder, our full circle is 2 pi radians. So that's going to, for our fourth quadrant, be between 3 pi over 2 and 2 pi. So when I'm giving you an angle, say if I gave you, 3 pi over 4, I can say, okay, where does that fall within our quadrants? And that'll kind of help us out as we're going through our different features. For instance, finding coterminal angles. So let's do that. Ooh, that moved very strangely. So if we are finding coterminal angles, I'm not always going to require you to draw them, but drawing them does help a lot. So you may want to practice doing that, even if it's just on your own piece of paper and not on a Go formative. So So if we're finding coterminal angles, remember, those are angles that share an initial side as well as a terminal side. That's why the vocab is so important. So let's take a look. So if I draw something like this, where again, our initial side is going to be right here. And I'm going to say that we have a terminal side. Oops, that's still a highlighter. My bad. We have a terminal side right here. I'm going to give you this angle. Because here's the cool thing. We don't actually have to deal with angles that are less than 2 pi. Sometimes they're going to be greater than. So I'm going to say that for us, theta is 13 pi over 6. And again, this is our terminal side. So if I want to find another angle that also shares the same initial and terminal side as 13 pi over 6, why don't I just take the shortcut and go from here to here instead of going all the way around? So in order to do that, what we're really doing is we're starting here at our terminal angle and we're backtracking by a full circle, which for us is 2 pi. So we're going to backtrack a full circle, and that's going to leave us with this angle right here. So we're going to take that 13 pi over 6, and we're going to subtract 2 pi, or 1 full circle. I am going to change 2 pi into 12 pi over 6 so that I can subtract my fractions. And that, oops, there we go. That is going to get us just pi over 6. So what's an angle that's coterminal to 13 pi over 6? Oh, pi over 6. It shares the same initial side as well as the same terminal side. So that's something that can work. So we're just subtracting 2 pi. You can also do find a terminal angle by adding 2 pi and just going another full circle around. Let's do another example. So let's see this one. Again, we're sharing this initial side right here. I'm going to have our terminal side be over here now. There we are. And we're going to have the angle be from here to here. So now it's not greater than 2 pi. And again, this is our terminal side. In this case, we're going to say that theta is equal to 3 pi over 4. So again, that's something that's found in our unit circle. So something we can do, if we want to find something that shares the same initial side and terminal side, we can go backwards or in the negative direction. So now that we're going clockwise, we're going to be finding something that is negative. So again, you can think about this as starting at your terminal side and just going 1 full circle all the way around and backtracking. So again, we're going to take this 3 pi over 4, and we are going to subtract 2 pi, or we're going to subtract a full circle. And this is going to be 3 pi over 4 minus 8 pi over 4, so we can have a common denominator. And that's going to leave us with a negative 5 pi over 4. So we can say that this angle over here is a negative 5 pi over 4. So again, make sure here, I'm going to make a little note for us. Make sure the sign makes sense. So when I say the sign, I mean like the positive or negative sign. So in this case, since our original angle is less than 2 pi, when I subtract 2 pi, I should get something that's negative, showing that, hey, we're going to be going counterclockwise. Whereas in our previous example, since 13 pi over 6 is bigger than 2 pi, this, our terminal angle, is actually still a positive angle. If we had subtracted another 2 pi, we would have been going in the negative direction. So you can always find a positive or negative coterminal angle, just depending on how many times you're adding or subtracting 2 pi. Anyway, this is coterminal angles. We're going to be practicing with this a lot just through the whole term. But before we get to converting, which is the last step we're doing today, converting between radians and degrees, I just want to take a moment to talk about degrees. Now for us, degrees tends to be what we're most familiar with, and because of that, we're not going to be using them as much just because we're already kind of familiar. So just a reminder, oops, I don't know what just happened. Okay. So we're taking a look at degrees, or degree measures. Means that we are dealing in angles. So in class today, I talked about, taking pi and cutting it into certain sections. And if that works for you, do that. When I'm talking about this, I'm going to talk about cutting 360, for dealing with degrees. So I talk about cutting 180 into certain pieces. I'm going to talk about cutting 360 into certain pieces. So when I take a look at all of our 4 quadrants, we can say, hey, that top one there, that's like if I took 1/4 and multiplied it to 360. And then just keep in mind, within each of these quadrants, there's kind of like 3 angles that we're going to want to know. In this first quadrant specifically, it's going to be 60 degrees, 45 degrees, and 30 degrees. And if we're going to think about each of these in terms of 360, if we do 1/6 times 360, that's going to get us 60 degrees, so that's 1/6 of the whole circle. If we took 1/8 and multiplied it to 360, it's going to give us 45 degrees, so there's 8 of those pieces around the circle. And if we took 1/12 and we multiplied it to 360, that's going to give us our 30 degrees, so there's 12 of those pieces all the way around the circle. I personally like to think of it as splitting up 180 as opposed to 360 because that just makes it a little simpler in my mind. But I just wanted to show you that's what it's like for a full circle. So degrees was pretty quick, but let's talk about, going back and forth between radians and degrees, because like I said, we're more comfortable with degrees. If you want to take the time converting radians to degrees or degrees to radians, you can do that. So first we need to set up what are they the same as. So 360 degrees, I'm like, okay, that's equal to some amount of radians. We have to figure out how many. For us specifically, because we are using the unit circle, we can say that 360 degrees is equal to 2 pi radians. So let's simplify this. I can divide both of these by 2, and I get that 180 degrees is equal to pi radians. And that's something that you can see on the unit circle, which is fine. But here is where we're going to break that up a little bit. So if we were to try to go from degrees to radians, I'm going to divide both sides by 180 and say that, hey, 1 degree is equal to pi over 180. So if we're trying to go from degrees to radians, I'm going to take whatever degree I have, and I'm going to multiply it by pi over 180. And we're going to be using, in chemistry, you may have used like the train track method. I'm using quotations. The train track method when trying to change units of measure. We're going to be doing something similar here when it comes to degrees and radians. So if we're going degrees to radians, let's see, what if we start with 135 degrees? Well, we'll have 135 degrees times pi radians, I'm just going to shorten that to rad, over 180 degrees. Now, since I'm multiplying by a degree and dividing by a degree, those degrees cancel out and we're just left with our radians. So we're going to have 135 pi over 180, radians, or rad. Now, if we were to simplify 135 over 180, that's going to give us 3 pi over 4 radians. And hey, if you take a look at the unit circle, 135 degrees is in the same place as 3 pi over 4. But what if we did this with like I accidentally paused the recording, so hopefully nothing skipped out. But let's try this with negative angles. So if we do negative 270 degrees, well, we'll have negative 270 degrees times pi radians over 180 degrees. And again, multiplying by a degree and dividing by a degree, those are going to cancel out. And we're going to be left with negative 270 pi over 180 radian. And if we reduce the fraction of negative 270 pi over 180, that's going to be negative 3 pi over 2 radian, or rad. So if we're going, so let's see, negative 270 is like 3/4 of the circle in the clockwise direction, then that's exactly what negative 3 pi over 2 is. It's pi over 2 3 times in the negative or the clockwise direction. So that's going from degrees to radians. But what if we wanted to go from radians to degrees, which is, I think, more likely what you'll want to do? If we go back up to what we were doing earlier, back up here, instead of dividing both sides by 180 to get the degree by itself, we're going to divide both sides by pi to get the radian by itself. So we're going to say that 180 over pi is equal to 1 rad, or radian. So if you want to go from radians to degrees, you're going to take whatever radian you have and multiply it by 180 over pi. So let's try this. There we go. Okay. So if we want to go from radians to degrees, what if we try, again, negative. Let's try negative pi over 2. In your head, you might be able to do this, but I want to just kind of use this as an example. So we'll take negative pi over 2 radian times 180 degrees over pi radian. Now I take a look at this, again, multiplying by a radian, dividing by a radian, so we can cancel out those radians. We're going to be left with just our degrees. And this is going to be negative 180 pi over 2 pi, multiplying straight across. And I'm like, you know what? Those pi's are going to cancel each other out, and we're just going to be left with negative 80. Oh, I forgot to write degrees. Negative 180 over 2 degrees, which is the same as negative 90 degrees. So something I want to show you is that I may ask you to do this with something not on the unit circle, which is something you can do, especially because you don't always need a pi to have a radian. So what if I just gave you 2 radians, not 2 pi, that's a full circle. I'm just talking about 2 radians. What would that look like? Well, we're going to have 2 radian times 180 degrees over pi radian. We can cancel the radians. And we're going to be left with, let's see, 2 times 180 is 360 over pi degrees. Now, I can't simplify any more from here, so I'm going to just plug this into my calculator, and I'm going to get, that's about 114.59 degrees. So it is possible to convert with things that aren't specifically on, like this is in the unit circle, but it's not something I'm going to ask you to memorize. So that is a possibility. Feel free to look back over these notes, take 10 minutes, practice with your unit circle. Let me know if you have any questions.